students. I hope that you got various concepts on frictional force from my previous videos. Now in this video, I am explaining a problem where the frictional force is used to slide a chain over a table. Now a chain of length L and mass M is placed on a table. 1/3 part of the chain when hanging from the table, then the remaining part tends to slide from the table. If the chain is released when half part is hanging from the table, then we have to calculate the speed of the end of the chain during it leaves the table. Whenever 1/3 part of the chain is hanging, then the weight of this part tends to pull the remaining part which lie on the table, and there is a frictional force generates which oppose that pulling force. For that reason, the chain remain at rest or tends to slide. So for 1/3 part, mass is mass per unit length of the chain is m by L. So whenever 1/3 part is hanging here, then mass of that part, this is m by 3, and the weight of this part is m by 3 g. The weight is downward. This weight provides a pulling force on the remaining part here, and this part having a tendency to slide. Therefore, a frictional force generates in opposite direction. The weight of the part which lie on the table, this is 2/3 m into g. The reaction force provided by the table on the chain, that is R. Then we can say that friction, this is equal to the pulling force, that is mg by 3. Now friction is equal to mu into R, this is mg by 3. Mu is the coefficient of friction, then mu into 2 by 3 mg, this is equal to mg by 3. Therefore, the value of mu, this is half. So from this part, we calculate the value of coefficient of friction. When the half part of the chain is hanging from the table and it is released, then the frictional force gradually decreases as the mass of the chain remaining on the table gradually decreases. Therefore, we have to use the calculus here. Now we consider that x is the length hanging from the table and x is greater than 1/3 part of it. Therefore, the mass of the chain which is hanging this is m by L into x. If this is the table and this is the chain, here the weight acting, this is mx g by l. In this direction there is a frictional force. This same weight, that means this mg x by l, this provides a pulling force on the remaining part which is on the table. Therefore, in this direction, the same force mg x by l is acting, and in opposite direction friction acting. Now the mass of the remaining part, this is m minus mx by l, and this is the weight. This is the reaction force. Therefore, friction F, this is mu r, this is half into m 1 minus x by l g. Therefore, the net force this is F, this is mg x by l minus friction. So, net force mg x by l minus mg by 2l, l minus x. The acceleration acting here, this is A, this is force by mass. So, G by L, x minus half L minus x. Now we want to calculate the velocity of the end part of the chain when it is released. Then we can write that acceleration A is equal to dv dt. Here time is not required, therefore we can write dv dx into dx dt. Therefore acceleration is equal to dv dx into v. We know that ddt of x, this is v, velocity. Therefore we can write that acceleration is v ddx of v is equal to g by l x minus half of l minus x. Therefore v dv, this is g by l x minus half of l minus x dx. Now we can integrate it. So whenever length is L by 2, at that time it is released. So velocity at that instant is 0. Whenever length is L, at that time velocity is v. We know that integration of v dv, this is v square by 2. Now here g by L. Now if you simplify it, then this is x square by 2 minus lx by 2 plus x square by 4, and the limit is L by 2 to L. Then v square by 2, this is g by L 3x square by 4 minus lx by 2, limit is L by 2 to L. Then V square by 2, this is G by L. Here 3 by 4. We are using the limits here. This is L square minus L square by 4 minus L by 2. This is L minus L by 2. So V square by 2, this is G by L. Get 3 by 4 into 3 L square by 4 minus L square by 4. So V square by 2, this is G by L, 9 by 16, L square minus L square by 4. So V square by 2, this is G by L, 5 L square by 16. Therefore, V is root over of 5 G L by 8.